This is the Secants and Tangents tutorial. Let's begin by discussing the chord-chord product theorem. The products of the lengths of the segments of two chords that intersect in a circle are equal. So, in this case, we have chord FT and chord SU. Now, the chord-chord product theorem states that if we multiply this segment, FV, times this segment, VT, right here, that should be equal to the product of segment SV and segment UV. Now, what I'd like to do is just put in some practice here so that you can really get this product theorem down. So I'm going to tell you that segment FV has a length of 2 meters, and segment VT has a length of 10 meters. And lastly, segment SV has a length of 4 meters. What I'd like you to do is solve for the length of segment VU. So I'll go ahead and write those in. FV is 2 meters, VT is 10, SV is 4, and VU is going to be our x here. Now let's use the chord-chord product theorem to solve for segment VU. We know that FV, which is 2, times VT, which is 10, should be equal to SV, which is 4, times VU, which is x. So 2 times 10 is 20, and 4 times x is 4x. We're solving for x in this case, so I'm going to divide by 4 on both sides of the equation. And we get 5 is equal to x. So in this case, VU has a length of 5 meters. Now that we've got the chord-chord product theorem, let's move on to the secant-secant product theorem. The secant-secant product theorem states that the product of one entire segment and the section of it that is exterior to the circle is equal to the product of another entire segment and the section of it that is exterior to the circle. So let's break that down real quick. The product of one entire segment and the section of it that is exterior to the circle. So let's start with dr. Here's our one segment. So here's one entire segment, dr, times the section of it that is exterior to the circle. Well, that would be this part here, from S to R. So that's what they're referring, and they said product here, which means multiplication. So the product of that whole segment, dr, and the piece of it that is exterior to the circle, which is SR, is going to be equal to the product of another entire segment. So product, again, multiplication, another entire segment. So in this case, it's going to be this segment, since that's the only one in the problem other than the first one. So that entire segment and the section of that that is exterior to the circle. And the part of that that's exterior to the circle is going to be this part here, which is QR. So if you multiply the entire segment dr times its exterior piece SR, that should be equal to PR times its exterior segment QR. Now let's try a practice problem to work that out. So if I told you that dr had a length of 10 inches, and SR had a length of 4 inches, and then PR had a length of 8 inches, could you solve for the last piece, QR? Well, yeah, you could use the secant-secant product theorem. So dr, which is 10 inches, times SR, which is 4 inches, should be equal to PR, which is 8 inches, times QR, which we don't know, so I'm just going to write that as x. So on the left, 10 times 4 is 40, and on the right, 8 times x is 8x. We want to solve for x, so I'm going to divide by 8 on both sides of the equation. 40 divided by 8 is 5, and the 8's over here are going to cancel, and we'll be left with x. So for this problem, segment QR has a length of 5 inches. So I'll write that in for this segment. QR is 5 inches. Now that we've discussed the secant-secant product theorem, let's discuss the secant-tangent product theorem. The secant-tangent product theorem states that the product of the entire segment and the section of it that is exterior to the circle is equal to the length of the tangent squared. So remember, a tangent is any line that only intersects the circle at one place, at one point. It doesn't go into the circle because then it would have to come out of the circle and it would have 2 points of intersection on the circle. So in this case, GH is going to be our tangent. And remember that a secant comes from an external point and goes into the circle and dead ends there in the circle. So our secant here is going to be GE. So I'll write that in here. This whole part here, GE, is going to be our secant. So essentially what we have is the secant, the whole thing, GE, times that portion of it that is exterior, right here, exterior to the circle. The product of those two, so by the way, that exterior portion is going to be GF. The product of GF and the entire length of the secant, GE, is going to be equal to the tangent, so again, GH, squared. So let's go over a practice problem that you might actually see. For this practice problem, I'm going to tell you that segment GF has a length of 12 centimeters, and FE has a length of 15 centimeters. And GH, I'm going to give a length of x plus 8 centimeters. And I'd like you to solve for x. So what we can do is use the secant-tangent product theorem. We know that the entire length, GE, which is 12 plus 15, or 27 centimeters, times the segment that is exterior to the circle, which would be GF there, 12 centimeters, is equal to the tangent squared. So x plus 8 squared. So 27 times 12 is 324. And that's going to be equal to x plus 8 squared. So remember, you can't just square the x and then square the 8. What you want to do is actually FOIL this problem. So we're going to write this out. So we have 324 is equal to x times x, which is x squared, plus x times 8, which is 8x, plus another 8 times x, which is 8x, plus 8 times 8, which is 64. So we have 324 is equal, now I'm going to combine our like terms on the right hand side, so equal to x squared plus 16x, I just added the 8x and the 8x, plus 64. Now we want to set it up like a quadratic and solve for x, so I'm going to subtract 324 from both sides of the equation. And we'll get 0 is equal to x squared plus 16x minus 260. So now we want to go ahead and factor that out. So when you factor this out, you're going to get 0 is equal to x plus 26 times x minus 10. And we want to continue on with that. I'll continue on over on the right here. 0 is equal to x plus 26, and 0 is equal to x minus 10. We're going to set each of those pieces equal to 0 and solve. So in this case, I'll just subtract 26 from both sides of the equation. And we have negative 26 is equal to x. So that's one possible answer for this problem. And over here, we're going to add 10 to both sides. And we have x is equal to 10. That's our second possible answer. Now, it's impossible to have a negative distance. So, if negative 26 were our answer, negative 26 plugged into this formula here, plus 8 is still negative 18, and you can't have a negative distance. So the only actual answer in this case is x must be equal to 10. If you plug that in, 10 plus 8 is 18. And since we know GE times FG was 324, and that should be equal to GH squared, well, 18 squared is 324. So 10 is our answer.